This meeting is being recorded. Awesome. Good afternoon, everyone, and thanks for joining this session of Exploring Phenomena. My name is Sophia Anderson. I am an ASTA ambassador and host for today's webinar. This webinar will be recorded. I will be assisting the presenters by watching the chat box and answering any technical questions. The chat box can be found at the bottom of your screen. Our presenters today are Caroline Carlson and Monique Franco from Roosevelt School District. During the past year, 60 middle-level teachers participated in ASTA's intense professional learning program called A Deeper Dive, constructing three-dimensional units. Teachers worked in a professional learning community where they learned how to utilize the 5 tools and processes for implementing the NGSS. ASTA, along with the BSCS and the ADE, facilitated the training. With the new science standards, or AZSS, adopted, teachers learned how to create instructional units that implemented the 3 major dimensions: the science and engineering practices, cross-cutting concepts, and core ideas. These dimensions, along with instructional shifts presented by the standards, are new and challenging to Arizona educators. One conceptual shift that happened with the new standards requires teachers to move their instruction from fact-based to understanding phenomena. So as you know, students currently learn scientific facts, but are often not able to explain the importance of these facts and their interconnections to the world around them. To build capacity amongst Arizona teachers in developing and implementing the 3-dimensional instructional units that are aligned with the new AZSS, the Deeper Dive program had the following objectives. The first goal was to build capacity through collaboration with science leaders statewide, to learn to use tools that translate science concepts, practices, and performance expectations into instructional sequences that form a 3-dimensional science instructional unit, to think deeply about learning and teaching to develop a clear vision of science education that is coherent, focused, and rigorous, and based on the 3-dimensional best practices as outlined in the framework for K-12 science education, and to collaboratively align instructional units to the AZSS and to share throughout the state. The ASTA is delighted to have the team from Roosevelt to share their unit that they developed for you. So, Caroline, I'd like to turn it over to Caroline and Monique.
Awesome, thank you so much. So I'm going to go ahead and share my screen in a second, but I'm going to go ahead and put the slideshow in the chat. That way, if you want to follow along or click links as we go, you can go ahead and do so. And then as we are there, if in the chat box, you can please put your position grade and then why you chose today's PD. And again, the session is on exploring phenomena. Okay, awesome. Great. And so great, we'll make sure we focus on those elementary learners, which is really cool. Today, we're going to focus a lot on sequencing the phenomena. So a little bit about Monique and I. We're both former Roosevelt teachers, and I'm currently the science specialist. So there is my email if you want to reach out. And then we worked, as Sophia mentioned, we worked on the 8th grade Earth and Space unit over the past year and created an assessment for as well.
Hello, my name is Monique Franco. Thank you for joining today. So I used to teach with Caroline at Irene Lopez School in Roosevelt, and I am currently the Education and Outreach Manager for ASU's CAP LTER program, which is a long-term ecological research program.
Awesome. Sorry, I was trying to do the side-by-side view, and that's why it moved for a second. Go ahead, Monique.
Alrighty. So just to review our outcomes today, first we're going to start off by looking at what is and what is not phenomena. Then we're going to talk about how to use phenomena in with their 3-dimensional instructional sequences. And then we have some resources available to explore.
Yes, and I did italicize it just in case we don't have time, but I will share a Padlet where all the resources will be if we do not get to it in this session. Okay, so we're going to start out with a card sort of thinking about what is and what is not phenomena. So what I'm going to go ahead and do, and we'll just do this whole group as we did in our last session too, so everything's together. I'm going to put the link in the chat, and as you look at the cards, we're going to sort them into groups that are either definitely phenomena, like, yes, I think this is phenomena. On the left-hand side, if it's you definitely know it's not phenomena, it's going to go to the right. In this space in between, you could put cards that you're unsure of. And we're going to start discussing reasons why we put the cards in each category. So without like Googling the word phenomena, just like what you've heard and your experience with, and we're going to go ahead and sort these cards. And then excellent. I think Monique is putting that in the chat. And I'm going to go ahead and stop my share for a second. That way I can jump to that one and just show how to navigate this resource. Which you can also you can file, make a copy and use with teachers if you want to use in your own professional development. And so with these cards, you just literally drag them into things that you think are phenomena, things you are unsure. So I'm going to just go ahead and leave this view here and give us about, and so Bethany, if you want to unmute yourself, you can, or if you want to just kind of sort them out, I'm going to go ahead and give like 2 to 3 minutes to go ahead and look and organize things that we think is definitely phenomena, not sure, and definitely phenomena.
Okay, well, ecosystems is too broad of a category, so I know that that's not.
Oh yes, maybe I can move. I know some of them will need a stack, so I can help move that.
Yeah.
Okay, definitely not. I'm just going to switch this here to.
Okay. I'm pretty sure the one underneath it, the reintroduction of wolves, that's more of like yeah, I don't think that is.
Okay, cool. Switching some views.
And just for my type A personality, there are 3 in each category.
I love it.
No, I don't think that's 3 in each.
Oh yeah. It's but it's up to you. If you want to leave it here, we're gonna kind of like revisit.
Yeah, yeah, that's fine.
Okay, cool. Any last ones though that you think?
Well, maybe I'm rethinking the introduction one.
Oh, do you want to put it? I can put it on unsure.
Yeah.
Mm-hmm.
And what makes you rethink that one?
Well, just that, that's a good question. I mean, if we want to like explore the potential consequences that could be possibly, yeah, that's why I don't think it is, because I don't think it's defined enough, but we'll just go with that. The Holly's questions, the Holly's parents wondering, I think that could potentially be something to
like investigate
further. Yeah.
Yeah. A pattern I noticed just as you were talking, it made me think, is when I see the reintroduction, there's also like the introduction of zebra here. So possibly it's a phenomena of, introduction, reintroduction of certain species.
The snowfall. That's a question. So that might be. We'll leave it in that column.
Yeah, and it's good you noted that this one's a question. None of the other ones are questions. So could it be a phenomenon or not based on the question?
So
yes, excellent. And this is also available as like a card, a cutout card
A
sort
card,
too.
yeah, okay, yeah.
So that's when Monique and I did this. We had the physical cards, and we did a lot of battling with each other of like, this goes here, this doesn't go here, and it's really crucial in the conversation. So we brought up this question piece right off the bat, and I think a lot of us do that. Is like ecosystems. That is like just one word, very broad. So I'm going to go ahead and jump back to the slideshow, and then you can file make a copy of this one too as a digital. And the first link I sent was the card copy. So we kind of shared out like which ones, something important to note is like which cards were definitely not. So we just talked about that ecosystem one was the one we categorized as definitely not because it's very broad. Which cards were definitely phenomena. So there was a couple we put in that category. What rationale would we use to say that?
For me, it was something to investigate. If I could do some kind of either research or experiment, that was my criteria.
Okay, so if I can investigate or experiment on, that's going to be the criteria. And then so when you do this with teachers, like maybe we charted it out, and so I just verbally said them. That could be something you also put on a slide, and that way we can revisit. So real quick, while I'm on here, I'm just going to put investigate. Or what was the second category we said? Like labs?
I said research.
Oh, okay, investigate or research. Excellent. So just something that we can revisit when we look at the rationale. And then I'm going to go ahead and copy this link here because we're about to look at the actual rationale that was posted and what is not phenomena.
I shared it, Caroline.
Oh, you shared it? Perfect. And you can also, if you have an iPad or your phone, you can also just take a picture of it as a QR code. And so I'm going to give us a second to kind of navigate there, and then I will open up the Padlet to share which document we're using.
And what I really like about this activity is it's kind of like what we do with the students, right? We allow them to explore and kind of rationalize what they think is phenomena or whatever we are having them do. We have them explore it first, and then we provide that explanation.
Yes, awesome. So as I see we're getting there, I'm going to go ahead and I'll stop my share so I can open up that website. Because there's a lot that we put on there just as resources for teachers and for coaches and really anyone who wants to use it. So we're going to open up this first PDF, and I'll open it up in a second. But I do want to explain, if we don't have time today, there's phenomena resources here, some adaptations to virtual learning or distance learning, how to evaluate the phenomena, and then just everything else. I think I'll come back to at the end, but the slideshow is here, and even just how to put it in a unit and things like that, and the difference between a phenomena and a problem. So let's go ahead and open up this document. Let's see if I can full screen it. Sweet. And then we're going to go ahead and look at what was and what was not phenomena. So as you can see for our first card, number 1, ecosystems, that was not a phenomena. And the reason being, it's just a topic that doesn't describe anything or doesn't have students explain anything. Let's revisit, and we can kind of take a minute to look at some of these too. So I know one of them that we also kind of put in the for sure category, I want to say, is the one about Holly's parents. So I'm going to look at card number 6. So they wonder how to deal with the insects. It's a problem. So something I do want to address is your instructional sequences can be a phenomena or a problem. So here, and I'm just thinking back to that rationale, like we want students to investigate, question, or research something. So we were correct on that rationale, because here it prompts students to wonder about the relationships between the insects and the crops. But this problem can be redefined. Like we can make it better by adding specific details. Like, for example, maybe like, why is it that and I know I'm phrasing it as a question, but, just to incorporate into a problem about like, perhaps, like bees are a helpful insect versus like if you had maybe like caterpillars or something different, or like a different type of insect that might be harming or even harming certain vegetables. So that's something that can be improved. And then let's go ahead and look at the cards that, just for the sake of what is phenomena, let's look at some of the examples that were. And here's one of the ones, and I think we looked at the introduction and the reintroduction. So if I look at, and I'm going to call out number 4, because I know Monique has an activity to go with this one too. The reintroduction of wolves to Yellowstone in 1995 resulted in both expected and unexpected consequences. These observed changes in the wolf and elk population prompt students to consider why these changes occurred. And Monique has a really cool video that's going to show how to prompt those questions with students. And then similarly, if we just introduce something, students can, there are observable changes that are going to consider like, how did those changes happen? So really we want students to investigate phenomena. Monique or Bethany, is there anything, any of the ones that as we look over it, you wanted to like call out or had a question on or wanted to highlight as rationale for phenomena?
I think it's interesting to see it as written statements rather than, I would almost use, because I've definitely done the wolves activity
awesome.
before with students and stuff, but I've looked at it with using the graph that goes with it. And so I've used the graph as my phenomena, not necessarily a written statement. And so it just kind of, it played with my mind a little bit to see it kind of like, you know, written out rather than that visual to go along.
And I think the visual would be a great add. Like actually one of the resources on here, I have a ton of GIFs that are phenomena. And so there's no statement, but I ask students like what's going on here or question and wonder. So I think a graph is totally appropriate. But it can also help like for students that are kind of like this, where they want to see a statement to help them with the words they're supposed to be using. But to that point, I also wanted to add that, and I'm sorry, Monique, were you going to add anything to that?
Oh, no, you're good.
Oh, okay. I was going to say, now that you mentioned the question, I mean, the statement, I want to look at card number 7 was a question. It was like, how does the amount of snowfall? So this one is not a phenomena because questions alone, they do not describe like what needs to be explained or happening, but the statement it could be rephrased to then be a statement and be a phenomena. Because for this one, it's kind of like exhibiting like a one answer, right? Versus like if it was a statement, then the students generate their own questions to further investigate. But if you give them one question, it's really just like, okay, there's kind of one answer type of thing, and doesn't exhibit more thinking. All right, I'm going to go ahead and stop my share, but that resource is available just to kind of look and change our minds on. And I'm going to go ahead and just highlight then what is the criteria for phenomena. So when we look at phenomena, we want it to be something that sparks students' curiosity. Oops, sorry, I think I have, oh, there we go. It's sparks students' curiosity. It addresses the core ideas in the standard. And I say for core ideas twice, but pretty much we want it to be standards-based. And it can be investigated. So yes, got that point of we know for sure we really want students investigating a phenomena. Just some things to consider. It doesn't have to be phenomenal. Like sometimes we think of, I kind of think of my teachers are loving this guy on Generation Genius. And he's like this guy with this bedazzled lab coat and everything is like, ooh, and like all up in your face. But it doesn't have to be like even, and I should have put a picture of this, but even like, if you do that like hot water and cold water experiment of the food coloring and something as simple as observing that in hot water, the food coloring was faster. I mean, that's not something that's like, whoa, you know, nothing exploded, but at the same time, it is a whoa, because students are really looking at like, why does that happen? I never noticed that before. So just a consideration, does not have to be phenomenal. You know, something big, ooh, ah. And then pick something that will engage your students and have them take into consideration local relevance. So like in our unit, we did a problem with like the jaguars being affected at the border wall. You know, our first sequence was about the Grand Canyon was our first investigative phenomena. But think about, is there things going on even at the school level, at the district level, in your area? Where we're from, we have South Mountain in our backyard. So that's really cool to refer back to. Ability levels, interests, and experiences. So really knowing your classroom and what will engage your students. And then science is seeking to explain the cause of that phenomena. So really The phenomena is there to have students really investigate and research and wonder and explain why that happens. All right, and then I think Monique's going to go ahead and explain this in a sequence.
So when we're thinking about,
Oh, I'm so sorry.
sorry.
That was my bad. Go ahead.
It's okay. So when we're thinking about instruction based on phenomena, it's requiring the students to shift from learning about a topic and having them engage with the 3 dimensions to explain how and why. So instead of saying, oh, this is what happens, we're having the students really use those 3 dimensions in order to explain it. So I really like this visual because what we're doing is we're enticing the students, we're having them become curious about something and allowing that interest to drive that motivation for the students to seek the information that they need. And then, you know, what you get is having students to be able to reason about something. And what's great about phenomena is that the students are able to connect it to different things. And so giving them a phenomena is going to allow them to be interested in the learning, which then they can apply to other science concepts. So when we're looking at phenomena, we are going to be using this standard here. Develop and use models to demonstrate the interdependence of organisms and their environment, including biotic and abiotic factors. And so when we're looking at a standard, the first thing we want to look at is what is the standard telling us already. And so when we're looking at this, we can use the standard to then identify the core ideas. And so if I'm looking here, we are talking about biotic and abiotic factors. Those are somewhat core ideas. And what we do is we think about, based off of those core ideas, what phenomena can I use to describe and support those core ideas. So we start with core ideas. Let me see if I have. We start with those core ideas, and then we think about what phenomena requires the core ideas to be explained. And then what we do then is we're using the science and engineering practices in blue, develop and use models, to answer the question of how will students interact with the phenomena. And what's nice about the Arizona standards is that within the standard itself, it gives you cross-cutting concepts that you can use. So within the standard, it'll give you down below where it's bolded, where it says cross-cutting concepts. Sorry, I don't have like the little pointer because I'm not screen sharing, so my apologies. But if you look at the standard, it will bold cross-cutting concepts that go along with that standard. So if I'm looking at this standard, I'm looking at the interdependence. And so what I'm going to look at is systems and system models as my cross-cutting concepts. Okay.
Cool. And I did put a little arrow. Sorry, I put a little arrow where the cross-cutting concepts are. I don't know how to use the pointer, so I put that arrow there.
And so then what we get though is that cross-cutting concepts is what is the lens the students is going to use to study that phenomena. So if we know they're going to need to know biotic and abiotic factors, we're going to do that by using X phenomena, and they're going to explore X phenomena by develop and using models, because that's our science and engineering practice as identified by the standard. And then they're going to use it in the lens of, I'm going to think about this phenomena in terms of systems and system models. And so the standard itself gives you a lot of information about the 3 dimensions. And what you're going to do is you're going to use those core ideas to determine what phenomena you can use for that standard.
Awesome. And something I do want to bring up too, where it says performance expectation at the top, just think of it as standard.
The standard.
A lot of, absolutely.
Yes.
Oops, okay, let's see. There we go.
So then if we're looking at this standard, first thing we want to do is think about what core ideas do the students need to know in order to successfully acquire or be assessed on the standard. What things do they need to know? So if we're looking at this standard here and we know that biotic and abiotic factors our core idea here. What do they need to know about biotic and abiotic factors? What do they need to know about organisms and their environment in order to, for this standard? So since we only have you here, Bethany, you can just unmute and share what are some things you think that students would need to know in order to successfully accomplish tasks in this standard.
Right. So, I mean, just that one's living and one's non-living, and that the living organisms are really, I think, dependent upon the non-living things that are in the local habitat for their survival. So thinking about the requirements of living things, like what are the requirements of that something's living, and then also the needs of living things would be, I think, key for them to progress through this particular learning module.
Perfect. And this is how we went through when we were constructing our units. We were thinking about what are those core ideas, what are those science concepts that the students need to know. And so along with what you've said, Bethany, we have a list of different core ideas that could potentially go with this. So you talked about the needs of animals, right? Or living things. So we know that animals need air, water, food. We know that non-living factors can also affect populations. Animals eat plants and other animals. So you can see here are some of these ideas that students have to understand if we're going to talk about in the lens of systems and system models, how what they need to know about biotic and abiotic factors and the interdependence of organisms. And so we have this, we have these different core ideas here. And next thing you want to do when you're thinking about, when you're constructing a unit based around phenomena, after you've identified those core ideas, you want to think about, okay, now I have all these different ideas that I know students need to know. How am I going to categorize them in a way that creates a conceptual flow? And so if we're looking at these here, which core ideas do you think we could link together? And I'll give you a minute to just kind of read through them. And then you can just kind of think about how would you start to organize this conceptual flow.
And just a suggestion too, like when we did this, we did it on like sticky notes and then we organized our sticky notes. And like, if you're going to do this digitally with teachers, maybe like a Padlet or something so you can organize those sticky notes. But we're about to color code in a second, but we'll give a minute to kind of read out these options and organize.
Yes.
Okay, well, I see food webs, and animals eat plants and other animals, so that would go together. And as well as predator prey, the ones that have to do with predator prey, we could link up to the food webs as well.
Yeah, so I could see that being its own sequence, right? Like food web, talking about food webs and what eats what.
The ones that have to do with humans, we could link up together.
And just for the sake of time,
yeah,
and because you're the only one, and I don't know how fun it is for you to be the only one, but so, and what's great about creating these conceptual flows is there's not necessarily a right or wrong answer, but really it's thinking about what's the story you want to tell for your students. And so although you have an idea of how you would categorize these, how I categorize them might be different because I might approach it differently. But the idea is that we're creating a conceptual flow so that when we identify a phenomena, we can link up those parts in the conceptual flow so that we're telling a story for the students. Okay, you want to go to the next slide, Caroline?
Yeah, and I want to show your color code. So let me see if I can do that. I see.
So this would be an idea, and this might even be a way you do this PD digitally with teachers. We have the links to in the Google or in the PowerPoint if you want to see them in the notes. But then, so what you want to do is you want to categorize, and what's cool about categorizing your core ideas is it's going to give you an idea of how long this unit will take, or this sequence will take. And so if I'm looking at these, I'm seeing that there's, 7 different colors. I might choose to do a 7E instructional model as opposed to a 5E. So I might need to incorporate another explore, explain sequence to make sure that I'm addressing each of these in depth. So let's see. Okay, so then for this one, yeah, so for this one, if you want to go back, Caroline. But it's okay. So so for this one, so the next thing that I would maybe think about is, okay, I have all these ideas categorized. Now, how would I actually sequence them? So I know that humans are part and can affect environments, and I know that humans are animals, and so I know that animals need air, water, and food, and I know that animals eat plants and other. So if I'm looking at these ideas and I categorize them, now I want to think of how would I sequence them. So so then we have so I'm going to share a link, and it'll give you an option to kind of try to figure out how you would sequence it. So I'll put it in the chat. It's so strange doing it with just one person because I go back and forth and I'm like, do I want to just do it? But in the chat, it'll bring up.
Oh, that only had part of the link.
Okay, let me see.
And then I can stop my share too, so that way I can share what she's talking about, where I can edit.
Okay, perfect. All right, there you are.
Thank you.
And again, all these links are there. So, if you're in an instructional coach position, and you want to do something like this digitally, you definitely can. And then Caroline, you want to go ahead and share. So then what you see here is you see all these core ideas categorized. And then now what you're thinking about is, how would I sequence these ideas? How would I see, what would I do first? What would go next? How am I going to build upon these core ideas so that I can create a storyline for my students? So I'll give you a minute if you want to just read through what we've categorized as similar core ideas. And then if you read through them and you want to just start organizing, you're just going to click the box and then move them from left to right.
I think this is really helpful too if there's like curriculum committees or like, so I have some teacher leader groups and we like practice this, but it's sad because they kind of practice it solo when we should really be practicing it together and in a group and doing this work.
Well, my brain's going a million miles because I'm like, well, I could go with the order that it's there. I probably, not sure about the purple one. Yeah, because if we did it from like a perspective of like how humans impact, like we've learned all this and now, what's the human effect? You could almost put that at the end.
At the end, yeah.
It's kind of like a culminating thing.
Yeah, and I think work like this is important for teachers because I think sometimes teachers don't think full picture. And so doing an activity like this really shows how important it is to consider the entirety of a sequence, because then you really have to think about, how is your story flowing? And I think it's really helpful too, because then if you could build a storyline that builds upon each core idea or these categorized idea, then you have this really great story that's easy for students to follow.
Mhm.
And when I look at this too, it's even great to, I was just thinking about this exact one because my third grade teacher on my curriculum team is working towards something very similar. In third grade, they talk about food webs too. And we had this whole debate, like just a friendly debate. And we were talking like, what do we want to do first? Like, should food webs go at the end? Because first we want to talk about the structural adaptations. And then we decided to like bundle a little bit. We like had, we talked about plant structures first. And then we talked about the food web because I told her that's probably the biggest misconception is students don't realize like plants get their energy from the sun, right? Like, so then, like, how are they going to know that in a food web? So we spent like an hour together really coming up with this storyline. And it was great because it was like her and I together talking about it. Whereas like when I felt like I was a teacher, sometimes when I look at my flow, I'm like, oh, dang it, this should have gone first. But great conversations to have as you plan and at the end of the year too to reflect. We should have done this sequence first and then, right? So great activity to do.
Yeah.
And so kind of like the last slide with categorizing those core ideas, with sequencing, it might be different depending on how you want to tell that story. So I'm going to go ahead and just share the storyline we chose to share. And it might be a little bit different than something that you've decided to go with.
Okay, oops, perfect. Sorry, I thought I closed it, so I got scared. Okay, here it is. Perfect. And
So this is the story, the conceptual flow we decided to go with. So we're starting with animals, that humans are animals, animals need air. Then we're going into food webs, then we're talking about patterns of interaction, and then we're talking about predator-prey relationships, talking about then how humans disrupt patterns of interaction. And then we are looking at examining natural and human caused patterns of interactions. And then here at the end is really looking at the impact that humans had. And so this is what our conceptual flow that we decided to go with. Caroline, you want to go to the next slide? And then, oh, I'm sorry. And then at the top, which you may notice is that we decided to use the phenomena of the reintroduction of wolves into Yellowstone and the impact that the impact on the ecosystem had expected and it impacted the ecosystem in expected and unexpected ways. Excuse me. Okay, good, Caroline. So then, and then this, it's the same. So here, if you look at this here, the top portion's the same. It's going to be those core ideas. But what you may notice is I've identified the 5E, or in this case, it would be, oh yeah, in here, it would be the 5E, or I'm sorry, the 7E, because there's 2 explore, explain cycles. And so with this, there were so many ideas, so many categories, so many core ideas that we categorize that we decided, okay, a 7E model is going to be most appropriate because we're going to need another explore, explain cycle within that model. So down below, what you see down below is the investigative phenomena. And so we have our anchor phenomena, which is going to be the umbrella phenomena. This is what we're looking at whole picture. But within each of our lessons, we have an investigative phenomena. And so here, if we know that our anchor phenomena, what we're going to use to describe these core ideas is the reintroduction of wolves into Yellowstone, these investigative phenomena are kind of, you want to think of them as like the lesson phenomena. So even though we're going to be exploring the anchor phenomena throughout this sequence, your investigative phenomena is going to be those mini phenomena within each lesson that's going to focus on those categorized core ideas.
And then, did you need the last slide or is this good, Monique?
No, so if
Okay.
you want to look back at those, you can always see how that investigative phenomenon matches those core ideas. If you need more time on that one, Bethany.
Yeah, and something we had to kind of train on too, because it's first like, whoa, there's phenomena. And I think this is the next step, even in our own district, is really looking at anchor versus investigative then. So anchor being what you're going to focus the instructional unit to be. And then the investigative, those are smaller phenomena that are going to build multiple points throughout the unit of instruction. So investigative phenomena focuses on the learning of that sequence that helps students understand the scientific concepts related to that problem. So here's just like a really simple example in a graphic of like using the scenario of like bowling balls and even just different forces. So the anchoring phenomena is bowling balls roll into pins and make them crash into and fall down. The first investigative phenomena would be, well, you know, like an object like a ball can be pushed, whereas like ropes can be pulled, like your tug of war. Our second investigative phenomena could be, well, these moving things can also change direction. So like one of, and I believe it's one of the cross-training concepts is like, oh, changing shape, changing directions that I saw happening in like first grade. And then the last one is bowling balls can collide with the bowling ball pins. I'm sorry, the bowling balls can collide those bowling ball pins. So like you're really building onto this big idea of like forces within. It's almost like the anchor phenomenon is like about forces and sports. And then at the end, it really develops that.
So it's those little pieces that the students have to learn in order to understand the anchor phenomena.
And there's multiple ways, and we call it the launch, like Monique and I called it, is like how we're going to introduce phenomena in general. Like how are we going to introduce, you know, this idea, whether it's the anchor phenomenon, you're like, we're going to build this throughout the whole unit, or whether it's the investigative, how are we going to do that? So that can be done through videos, through images, graphs. So I think of like when Bethany said, oh, I put a graph up. So yes, and then problems or scenarios.
So we're going to go ahead and do an example, something that the students might do with the anchor phenomena that we discussed with the reintroduction of wolves into Yellowstone. So all the ways that, so Caroline mentioned different ways that you can introduce phenomena, and we're going to just look at an example using a video. And so something you might do with your students with your launch is to have them complete an I notice, I wonder chart. So as you're watching the video, what I would like you to do, and you can just do this on a separate, you know, piece of paper, just jot it down real quick, a quick T-chart. Or if you want to just take a mental note, that's fine too. But what I would like you to do is as you're watching the video, I want you to take note of things that you notice and things that you wonder. And so your wondering should be more of questions, right? So, you know, I wonder why, I wonder if, but those should be in the form of questions. So I'm going to go ahead and play this video and go ahead and jot down what you notice and what you wonder in your notice wonder T-chart.
Let's see if I can hit play. There we go.
Before you shared the screen, did you check the little box to share computer sound?
Oh, no, I did not. Okay, so let me see. And I wonder if I, let me see, share screen. And I'm so sorry, I'm going to ask this of you, but how did you do that? Or
Okay, so stop sharing.
Okay. Mm-hmm.
And then go ahead and share screen. And then before you click share screen, there's a little tiny box on the lower left that says share computer sound or something like that.
Yes.
Oh, and do you see it, Monique? Because if you want, you can also.
Okay, yeah, I can go ahead and screen share. And it might just be because there's no talking.
I think I hear like little squeaks.
Okay, yes.
Yeah. I was thinking that too. I was like, oh, it's like off and
It's
on. But I think
just
it is.
the sound. It's the sound of the land as well.
All right.
For the sake of time, I'll pause there. And so a couple of things I do want to mention is that I actually really like this video, one, because the kids are just, when they're watching a video like this, there's no audio, and so the kids aren't, having to listen to that. But I really like that they can hear the bird calls and the water running. And so it's really giving them an idea about this ecosystem here. And also,
Yeah, forces them to use multiple senses.
Yeah, and I think that the caption there, yes, the students have to read it, which teachers can also, they can also read off the captions to the student. But I just think it's a using a video is a really nice way to introduce the students with the phenomena. But this is also seeing how simple it is just to have a running video of something and then just text. It's an easy way for students or teachers who are teaching virtually. It's an easy way to kind of create a phenomenon. And so, you can record your own video and maybe put a text over it. And so I thought this was a great way to, one, talk about how to modify in today, what's happening right now, but two, just to give an example of how to launch the phenomenon. And so after the video is done, the students completing their I Notice, I Wonder chart. And then down below is just a sequence of events that you could follow in order to, in addition to the launch. And so after completing the I Notice, I Wonder chart, allow students to brainstorm or talk about, here it says create a model if that's the case for what you're doing, but you might even just have the students brainstorm with their table mates and talk about things that they noticed or they wondered. They can make revisions with their group mate and then communicate a whole group before then, and then at that point creating a driving question board. And so your I Wonder category is going to be a really great tool in order to drive students' learning by creating questions that they can focus on as they work throughout the unit. So Bethany, is there anything that you would like to share that you noticed or that you wonder from the video?
I think that, well, just the observations of like you said, the bird calls and the running water. And so that makes me think of, were those types of things, how were those things impacted over the last 25 years? I mean, were there more, were there less? Makes me wonder about the clarity of the water. Was there any kind of pollution there, or has that changed at all? Also just the landscape, how has that changed over the last 25 years? I mean, is it more green, less green? Are there more trees, that type of thing?
Yes.
So.
And what I really love about the I Notice, I Wonder is that you're having your students really think about things that they're noticing. and then time, which then drives the I wonder. I notice there's birds calling, or I notice the landscape is very green. I wonder how the wolves have impacted that. And so, Caroline, can you go to the next slide, please?
Well, you're screen sharing, right?
Oh, my bad. I'm so sorry.
No, you're good.
So this is an example of an I notice, I wonder chart that could be filled out with that video. And so noticing different animals, hearing water, and even the words that are on there. So students might not know the word acclimate. And so they might ask, what does the word acclimate mean? And so allowing students to fill out an I notice, I wonder chart also gives you an opportunity to identify those common student thoughts and how to address them in the future. And what's great about the I wonder is having those students generate those questions is a science and engineering practice. So asking questions, that's part of it. And so by creating a space students can do that initially, you're having those students already work through the 3 dimensions. Okay. So I mentioned in the sequence at the bottom, the last sequence potentially being creating a driving question board. And so here are some examples of what a driving question board might look like. And then there's a short video which you can watch on your own time about driving question boards. And really, when we're looking at driving question boards, it's a way it's a space for students to keep track of their learning and to motivate them to find answers. And so when students have these questions, it's really great because students have a reason to keep learning. They want these questions answered. And so it's really great because not only do they want these questions answered, but they're going to bring in their own learning from home. And so they might say, oh, when I'm at home, I notice my dog likes to eat this. My dog likes to eat meat. So I wonder, what are the wolves eating here? And so it's a really great space for the students to be involved in the learning, but also to create a pathway for their learning. And because students are all involved in this, that means that the learning is inclusive and it's relevant to the students. And it answers the question as to why we're learning this. And so it's really great. I love it. So, all right, let's keep going forward. So some things, so for implementing, sorry, Caroline, I don't have my okay, sorry about that. Okay. So then with implementing, one, you want to make sure you're designating a space that's visible for driving question boards. You want to identify the phenomena that's going to drive the unit, identify the phenomena that's going to lead to the driving question. So these are all teacher tasks, what you have to do when you want to incorporate the driving question board. And then you want to refer to the questions to guide investigations throughout the unit. So as you're working throughout the unit, this is a great way to continue to bring up that anchor phenomena. Okay, so what do we know about what kind of effects did the reintroduction of wolves have? And so what's great is as the students are learning, they're answering these questions. Some things to keep in mind is that driving question board is not standard rewritten. It should be culturally responsive, revisited throughout the unit. Students can freely post questions. It might be helpful to provide sentence stems, but you don't want to provide examples because you really want the students to come up with the questions. So I feel that, in my experience, students may feel like they don't know how to write a question, but that doesn't mean that they don't have questions. It's just them figuring out how to structure them. So even just providing sentence stems for the students or sentence starters. And then not all questions will be answered within the unit, which is really cool because after the unit's done, then the students are like, hold on, we didn't figure out the answer to this. What is the answer? And so what's great is the driving question board allows students or motivates students to continue learning on a topic or about a topic. And I think just out of respect for time, we'll look at this visual real quick, and then we'll answer any questions that you might have. So throughout us creating this phenomena PowerPoint, we came across this, I thought was a really useful visual for students. Now this is coming from NGS's 5 questions in classrooms routine, so it's a little bit different. But what I really like about this is that it shows how the phenomena and the 3 dimensions are integrated throughout a unit. So if you look here, we see that our driving questions are arising from phenomena, which is then guiding our questions. Oh, I think I have it too now. Okay, so here are phenomena, which we were introduced here. We're making sense to it, and it's helping us to develop questions, which then drive our instruction. We use those science and engineering practices to engage with that phenomena to figure out those core ideas. So these core ideas are pieces to the puzzle that we will ultimately use to address the anchor phenomena. So these investigative phenomena and the questions that we have throughout the unit drives our instruction and our learning to understand the anchor phenomena. So you can see here it's adding to our design, our model, or just our understanding. And then you'll notice that with each step, you're generating new questions, or you're revising questions that you had, you're answering them, or you're revising models that you have. And you can see how all these different components are integrated throughout a unit, all so that students are able to synthesize their learning and explain the anchoring phenomena.
Yeah, I like that image a lot.
Yeah, it's cool. I like it. So I thought it was helpful for me.
And as we close, because I know Sophia's going to jump in, everything's on the Padlet with resources, where teachers can look for phenomena, like articles for phenomena criteria. It's just kind of like advanced, like beginners and advanced. Feel free to play with that. And then, go ahead, Sophia.
Oh no, I hate to be that person because this is so good. Thank you both for doing such a great job. So we've reached the end of our time for today, but I really want to thank Caroline and Monique for Roosevelt for sharing their learning with us, knowing that our new science standards require teachers to shift the way they teach. We appreciate you helping and support our science community in innovative ways to reach students through the 3 dimensions. So thank you, Carolyn and Monique, for sharing phenomena. And again, the Arizona Science Teacher Association, the ASTA, has other exciting learning experiences coming up, and I hope you check out the website very soon. So thank you both. That was great. Awesome.
Thank you. Thank you for joining us, Bethany, and for being,
oh yeah,
up for, whatever we threw at you. And if you have any questions, we'll stay on if you have any.